Right. Good evening, everybody. Today, I will start with a new topic, which is nuclear power plant. From the beginning, I have been discussing power systems one. We have discussed regarding various types of energies coming with renewable and non-renewable. In non-renewable sources, the first I have completed about thermal power plant. The next came was hydroelectric power plant. In the last class, I have ended the hydroelectric power plant. Right. Today, we are going to start with a new power plant, which is nuclear power plant. I think we all are aware that what is the word nuclear. Okay, right. The power plant which is working on nuclear energy is called as nuclear power plant. If you are able to generate electrical energy by using nuclear energy as input, then you can call it as nuclear power plant. So I already have said that the output for every type of power plant is electrical energy. Coming with nuclear power plant means, as we are using nuclear energy, so nuclear energy will be the input. Let us deal, or let us try to understand what are the basics of nuclear energy and what are the merits and demerits. Why nuclear energy, is competent to thermal power plant. Why nuclear power plant has become competent to thermal power plant. Okay, right. How what all things we need to study, and how to understand nuclear power plants working construction principle. Right. Let us start with the basics of nuclear power plant in this class. Right. I will deal with what first we will let know, or we will come to understand, or we will try to understand the definitions of what is energy, what is an atom, what are the particles of an atom. Okay, right. What is energy? Let us see. Okay, right. And on the completion of this, at the end of this lecture, you will be able to know about, or you will have a brief idea on introduction to nuclear energy, nuclear fission reaction, nuclear fusion reaction, merits of nuclear energy, and demerits of nuclear energy. These all we will deal for today's class. Right. How nuclear energy came into picture, let us have a look. The atomic theory was developed by Dalton in 1808. Right, Dalton's atomic theory. It's a famous atomic theory which we will learn in our school level only. Right. Next is the electron was discovered by J.J. Thomson. We already, after Dalton's atomic theory, we also know that J.J. Thomson was the person who would have discovered electron. Okay, and the charge of electron is minus 1.602 into 10 to the power of minus 19 coulombs. Even we know the mass of the neutron, 9.31 into 10 to the power of minus 31 kg. Right. In the year 1898, Curie discovered radioactive materials. Our nuclear energy is related, or it deals with radioactive materials. Whatever the nuclear energy which we are able to generate, or whatever the nuclear energy input which we are giving to this power plant, that is just nothing but radioactive energy. So, this radioactive materials, what are radioactive materials, I'll discuss later. Let us know that there are radioactive materials which are available in nature, and the discovery of radioactive materials have been done by Curie. Rutherford is another scientist. After Curie, Rutherford has discovered alpha, beta, and gamma rays in 1899. Right. I was telling that Rutherford discovered alpha, beta, and gamma rays in 1899 after the discovery of radioactive materials by Curie in 1898. Right. What is an atom? Let us discuss. What is the structure of atom? Structure of an atom. See, in the left part of the slide, they are showing the structure of the atom. Okay, in between there are red and green there are red and green dots, and surrounding the atom there are blue dots. Okay, so let's just have a look on these dots, how these dots are placed on around the how the dots are there in the left part of the slide, so we can understand what is an electron, what is a proton, and what is a neutron. Right. What is an electron means atomic number and mass number. First, we should understand what is atomic number and what is mass number. Atomic number is the number of electrons in an atom is known as atomic number. Okay. I mean, how many atoms are there? The number of electrons which are there in an atom is called as atomic number. Okay. Usually numbering will be given right like in a class, how we give numbers to the students like pin numbers, etc. Similarly, all the materials also have been classified and they have been given atomic numbers. Okay, how these atomic number to that element they have given is it is based on the number of electrons which are present in an atom, and then this atomic number is represented by capital Z. Okay, so atomic number means number of electrons in an atom is called as atomic number. Suppose that hydrogen is having atomic number 1. It means that there is only one electron in hydrogen atom, and that is represented by Z, means Z is equals to 1 for a hydrogen atom. Coming to the mass number. What is mass number means the total number of protons and neutrons in the nucleus is known as mass number. Right, we have learnt about electrons, the number of electrons. Just give the information regarding number of the regarding the atomic number. How mass number we can find out means number of protons and number of neutrons in the nucleus is known as mass number. The total number of protons and neutrons is called as mass number. See, in a nature, as we know that all the atoms are stable, means all the uh, all the atoms are stable in the nature. We know how we tell that they are stable means the number of electrons will be equal to number of protons. Okay, neutrons will not have any charge, just they will add the mass to the atom. Okay, right, and here mass number, it is denoted by capital A, and total number of neutrons is equals to atomic number, mass number minus atomic number. Okay, number of neutrons is equals to mass number minus its atomic number, which is A minus Z, where A is the mass number and Z is the atomic number. Right. Next, coming to the isotopes. So what do you mean by isotopes? So let us see the definition of isotope. The atom of an element which have the same atomic number but different mass number is called as isotope. Okay, there are many isotopes available for different types of for different types of atoms, or for different materials. Uh, we have same atomic number but different mass number. Such type of materials are called as isotopes. Means atomic number Z should be the same and mass number should be the different. Hydrogen isotopes means H11, means all the three hydrogen atoms are having same atomic number, which is 1, but they are having three different mass numbers. One hydrogen isotope, the first hydrogen isotope is having mass number as 1, second hydrogen atom is having mass number as 2, and third hydrogen atom is having mass number as 3. Similarly, oxygen isotopes. Oxygen isotopes also, we are having three isotopes for oxygen whose atomic number is the same, which is 8, whereas its mass number is 16, 17 and 18. Even you are also having isotopes for uranium. The mass number of uranium is 92, whereas the atomic number of uranium is 92, but the mass numbers of uranium are 234, 235 and 238. So what does isotope means? Give us the information means it has the same atomic number but different mass numbers. Okay, isotope of hydrogen. Okay, hydrogen 1 1, it is called as hydrogen. Hydrogen with 1 2 is called as deuterium, and hydrogen with 1 3 is called as tritium. So there are three isotopes of hydrogen atom, which are hydrogen, deuterium and tritium. What is radioactivity? Okay, radioactivity means what? The phenomenon of spontaneous emission of certain kinds of invisible radiations by certain substances are called radioactivity. Like in nature, uh, we are having different substances which are available in nature. Okay, we have different. We have I mean, every substance will have its different property, like a boiling property, melting property, its conductivity, its ductility, its resistivity. Okay, whatever it might be, I mean, how it behaves at cool temperatures, how it behaves in vacuum. This all, I mean, for every substance, it will be different. Even in nature, the beauty of nature is that we have lot many substances we need to understand and study. Okay, there are some substances which are available in nature, and these substances are able to produce or able to emit some invisible radiations, means they have capacity to give some invisible radiations which are called as alpha, beta and gamma rays. So this material, these type of substances are called as radioactive substances, and as they are able to, I mean, and the property of emission of radiations like alpha, beta, and gamma rays from radioactive materials or from some by certain substances, it is called as radioactivity. Nana? Nana? The phenomenon of spontaneous emission of certain kinds of invisible radiations, alpha, beta, gamma, by certain substances are called as radioactivity. Right. Coming to the next slide, what are nuclear fuels? Nuclear fuels means what are the fuels or what are the inputs which we can give for nuclear power plant. The fuels generally used in nuclear power plant are uranium, thorium, and plutonium. Okay, these are the three materials, or these are the three substances which produce alpha, beta, and gamma rays. Means they exhibit the property of radioactivity, and they can also be called as radioactive materials or nuclear fuels. Okay, uranium, again there are three isotopes of uranium. I already told about isotopes. Okay, I mean they have written in bracket about the isotopes with along with their numbers. Okay, the atomic number of uranium is 92. Coming to thorium, thorium is with atomic weight 232, and plutonium is with mass plutonium 239. Right, coming to the features of nuclear energy. Okay, what is nuclear energy and what are the features? What is the speciality of nuclear energy? Why we are preferring to use nuclear energy? What are the advantages? What is the reason behind the emerging nuclear technology? Right, 1 kg of uranium with isotope with the atomic weight 235, 1 kg of uranium 235 is equivalent to 3000 tons of high graded coal. Okay, 3000 tons of high grade coal is just equal to 1 kg of uranium. See, think or just once try to analyze 3000 tons of coal means how huge. I mean, we need to, if suppose the place of thermal power plant is far away from coal reserves, or it is far away from Singareni collieries, then what happens? I mean, it takes for 3000 tons of coal to get transported, it takes lot of time, takes lot of money, loading and unloading charges. Almost the system will be very complex. Just think of uranium instead of instead of coal. I mean, just 1 kg of uranium is sufficient for us, means how easy the transport will be done and how easily things can be executed. Okay, so definitely if we compare in some aspects with thermal energy, nuclear energy is just like amazing. Okay, 1 kg of uranium is just, I mean, how easily we can transport. Next, abundant availability of nuclear fuel. Next plus point or the next advantage, whatever I want to say is, if suppose you are planning for some power plant, but first thing is I mean, while planning a power plant, how much reserves we are having, that also we need to observe, or that also we need to have a grip on that. Okay, if suppose we have a power plant which I mean, for which input, if it is not available properly, or if you don't have good reserves in the country of that fuel. Okay, So then definitely it will be a failure in building such a power plant. Okay, so even availability of nuclear fuel also for in our country, it is, I mean, abundantly it is available. Nuclear energy is abundantly available. Next, bulk power can be generated. Where this nuclear energy, we can generate more amount of power. Okay, means 1 kg of fuel is only, I mean, equal to 3000 tons of coal. Means with less quantity of input, obviously we are generating more amount of power. So these are the features of nuclear energy. Coming to nuclear fission and the nuclear fusion are the two important definitions, or are the two important phenomenons which are very important and which should be learned while studying nuclear energy. Coming to nuclear fission, fission means breaking or separation. Okay, breaking or separation is called as fission. How nuclear fission is happening? Let us see. The splitting of a heavy nucleus into two or more smaller nuclei and accompanied by the release of thermal energy is known as nuclear fission. The the splitting of heavy nucleus into two or more smaller nuclei. If a larger nucleus is getting splitted into two or more smaller nuclei, what happens whenever something is trying to break out, or something, I mean, something is changing its shape, then definitely there will be some thermal energy released. Along with this thermal energy, or I mean, along with the, the splitting of heavy nuclei into heavy nucleus into smaller nuclei, along with the smaller nuclei, some radiations or some rays will try to come out. So this phenomenon is called as nuclear fission. Okay, the splitting of heavy nucleus into two or more smaller nuclei and accompanied by release of thermal energy is called as nuclear fission. See, a slow neutron is coming and it is getting collided with uranium 235, which is a substance with heavy mass. So this uranium 235 is getting splitted into two. Okay, and it is getting splitted as lanthanum 148 and bromium 85. Along again, three neutrons are released, and an enormous amount of heat energy is released, and even gamma rays are also coming out. Okay, this is one possible splitting of uranium 235 nucleus when a slow neutron is bombarded. Okay, this is one possible way of then this one possible division means uranium 235 will split into, I mean, it can form many smaller nuclei, but this is one type of division which they have shown in the given slide. Right. Next is coming to nuclear fission. Again, see, I mean, it is a big nucleus which is getting divided into two small. One smaller nuclei is upwards and another smaller nuclei is downwards. Along with it, more amount of heat energy is coming outwards, which is on the right, which is on the, I mean, the heat part is shown on the right side of the slide. Right. Coming to what is fusion. Right. I told that nuclear fusion is a second phenomenon. Okay, or it is a second important definition which we need to understand while studying nuclear power plant or nuclear energy. What is nuclear fission means? The nuclei of atoms are joined or fused together and is known as nuclear fission. The nuclei of atoms, two or more atoms nuclei, if they get fused, I mean, two smaller atoms, if they are trying to fusing means they are trying to form a larger nuclei. Smaller nuclei, they are trying to fuse, or they are trying to get joined, and they are trying to form a bigger nuclei, a bigger nucleus. This is called as fusion. See, in the given diagram at the right side of the slide, see, they are helium, deuterium, tritium, and neutron. Okay, when they are trying to combine, okay, even then, a neutron, I mean, right? Deuterium and tritium, hydrogen, deuterium, tritium, no? Helium, deuterium, tritium. See, tritium and deuterium are trying to fuse, and they are forming helium with one neutron is getting released. Okay, right. Right. Coming to the next part, next slide. What is nuclear fusion? In nuclear fusion, the nuclei of atoms are joined together or fused, and this also produces a huge amount of energy. Both the phenomena are associated with huge release of energy. Okay, either it may be nuclear fission or it may be nuclear fusion. In nuclear fusion, the nuclei of atoms are joined together or fused and produces a huge amount of energy. Two, two deuterium nuclei in a strong electrical discharge. Okay, they try to form a helium nucleus. Okay, and more amount of energy will get released along with one neutron. If you want, you can check the atomic balance. Two hydrogen atoms with atomic number 1 and mass number 2. H12 plus H12 means total you are having you are having 4 mass number and 2 atomic number. If you add, it is getting combined and forming helium 23. Means helium atomic number is verifying if you add 2 hydrogen 2 deuterium atoms. Coming to the mass number, when 2 hydrogen nuclei, if you add, then you will form helium 3 and 1 neutron will be remained. That, I mean, it will be, and this 1 neutron will be released after it forms tritium. 2 deuteriums, when they form uh, this helium with the 2 3, okay, and then 1 neutron will be released. Along with this, enormous amount of energy also will get released. Coming to the merits of nuclear energy, okay, what the important or the merits of nuclear energy are: nuclear energy is clean energy. Okay, again, this is like a clean type of energy, less fuel requirement. This I have already discussed. I mean, it almost 1 kg of uranium is equal to 3,000 tons of coal. So obviously less amount of fuel will be required, low fuel cost as we have more reserves in the country. And other than this, this they can't be used for much, for different purpose. So you can use this nuclear energy and you can generate electrical energy. So fuel cost is also low as we have abundant available reserves in our country, low operating charges, bulk power generation, less area usage. Right, as you are using less amount of material, less area of usage also will be satisfied. Next, bulk power generation, you can generate more amount of power. If suppose if you increase the quantity of the fuel, then definitely you can achieve, or definitely you can generate a bulk amount of power. Next, low operating charges. Even operating charges also are a bit low when we are comparing it with thermal power plant. Even the nuclear energy is also a clean energy. Like if coal means, again you need to separate. Okay, after that you need to crush. This all work will not be there. It will be a clean energy, and you will obtain the uranium atoms or the uranium substance, and you will try to undergo nuclear fission reaction, and more amount of heat energy will be released, and this heat energy will be used in converting this heat energy will be used, and it will be converted into electrical energy, which is our nuclear power plant. Merits of nuclear energy, there are some other merits. Flexible output control. What is flexible output control means, if suppose however, if suppose you need to, according to the load demand, you need to increase the generation or you need to decrease the generation, that also a bit you can change according to yourself, according to the necessity of the load. Next is reliable operation. Right, this power plant, it will be like a base load power plant, means all the time it will run. Okay, no need to worry like water is there or not. I mean, reservoir, if you are taking hydroelectric power station, water is there or not. Suppose if you are taking renewable power plants like tidal energy or mm, solar energy, I mean, availability of fuel should be there, like availability of light energy should be there, or availability of wind should be there. But here there is nothing a problem. Why? Because already you will put in reserve some 3 to 4 months of stuff, that is the nuclear fuel whatever you require. That for 3 to 4 months it will be taken and it will be kept in reserve for this operation. So I mean, most probably there won't be any stoppage for production of electrical energy. So we can consider this as a base load power plant, and the operation of it, I mean, it provides a reliable operation for us. Next is no greenhouse effect. Greenhouse effect also is not there. Why? Because you are not performing combustion here. Okay, as we are not performing combustion, so there is no greenhouse effect also. If we take thermal power plant, means in the boiler furnace only we will undergo combustion, we will draw air from the outside. Okay, I mean from draught fans, and you try to undergo combustion in the boiler furnace in and with this combustion whatever the heat energy will be released, that will be used to convert our water into the vapor. Okay, here as you are not performing any combustion, you are not having any greenhouse effect. Means no release of carbon dioxide will be there for your nuclear energy. Coming to the demerits or risks of nuclear energy, I accept that there are many advantages, or there are, I mean, it is profitable to use nuclear energy. I mean, compared to thermal energy, it is having, I mean, countable or, I mean, it is having, I mean, it, it is having very good amount of advantages. But I mean, I will try to tell that, I mean, this nuclear energy is just like a risk form. I mean, this has more amount of risk. Okay, it's just a bit risky to have or to operate a nuclear power plant. See, it is having a high capital cost. Why? Because whatever the nuclear energy, even though you are using nuclear energy, which you are using is less, but I mean the operating equipment, whatever the installation cost or whatever, you need to use a huge, I mean, you need to use modern technology equipment. Okay, I mean, uh, which design, or I mean designing of this equipment which is used in nuclear power plant, obviously it will be costly. Okay, right. So it is having high capital cost, or it is having high installation cost. Next is expensive fuel treatment. Okay, even fuel treatment is also uh, uh, high only. Nuclear reserves are also available, but fuel treatment means whatever the steps in which you are trying to uh, you in the steps in which you are trying to convert nuclear energy into electrical energy, even that fuel treatment steps also are a bit expensive. Next is high qualified persons are required. I mean, I have told that hydroelectric power station minimal staff is required. Okay, even I mean, we don't require much skilled labor, whereas for thermal power plant we required skilled labor. Here you need to have highly qualified persons. Why? Because I mean, the machinery or the equipment, everything will be very costly. And I mean, this energy is a bit risky type of energy. Why? Because huge amount of energy will be released during fusion or fission. More and more amount of energy will be released. So in order to control that energy at a time, if suppose that energy becomes uncontrollable, I mean the chain reaction which occurs in our nuclear fission, if it becomes uncontrollable, then definitely, I mean, we need to require a highly qualified person. I mean, semi skilled or unskilled laborers are, I mean, with them the work will not I mean, with them the work will not go ahead. Definitely we require highly qualified persons. Next is disposal of waste is difficult. I have told that greenhouse effect is not there here, but I mean whatever the nuclear wastes which are coming, I mean which are the byproducts of our nuclear fission or fusion reaction, the disposal of these byproducts is also difficult. I mean we can't dispose them easily. Next is radiation effect, and laser or whatever the radiotherapy, whatever they do to, I mean they do that the treatments they use in our medical technology, there also I think we will hear that the radiation effect will be there usually in the nearer to the x-ray room, like that it will be written. I mean, heavy radiation here. Radiation is being used. It is not suggestible for pregnant women to stand here or to move in this area. Like that, this nuclear power plant. I mean, whatever the radiation which will come out when this nuclear power plant is operating, whatever the radiation which will come out, this effect of radiation will be up to 30 kilometers. Means we need to be very careful. We need to be very careful regarding the aspect of radiation. Why? Because as this if the I mean it will affect our health. Okay, there are chances that if the emission of radiation is very high, or if some person is exposed to some high amount of radiation, there are chances that he might get serious, or in some detrimental cases it may lead to death also. So definitely this radiation effect also is a big demerit for usage of nuclear energy. Right. Next, demerits or risks of nuclear energy. Some large capacity cooling towers are required, as we use in thermal power plants. Here also we require large capacity of cooling towers are required here also for our nuclear energy. Next, maintenance is also expensive. Okay, why maintenance is expensive means the whatever the equipment you are using is very costly, so it should be properly maintained, and a highly qualified person should be there for running a nuclear power plant. So highly qualified personnel means we need to pay more amount of salary. Okay, so definitely maintenance will be costly. Next, management of thermal discharge is expensive. Thermal discharge means whatever the wastes or whatever the wastes which are having high which are which which uh, which are of high temperature, whatever the thermal discharge, whatever the discharge which is there, as it is having a lot of heat, even discharge, disposing this thermal wastage is also expensive. It is not easy to even discharge the wastes which are the byproducts or which are the wastes of the nuclear power plant. So these are the demerits of nuclear power plant. Next is, in this session what we have learned is what is energy. Okay, and what is atomic number, what is mass number, what are nuclear fuels in our country, what all the nuclear fuels are available, what is nuclear fission, what is nuclear fusion, merits and demerits of nuclear power generation. Okay, these all are the merits and demerits. Okay. As I can tell, the basic definition for energy means energy is defined as the formula for energy is defined as the rate of work which is done in a particular time. Okay, like energy is equals to power into time. Okay, your power is given in watts and your time is given in seconds, or units of energy usually they are given as kilowatt hours. Okay, means 1 unit is equals to 1 kilowatt hour. What is nuclear energy means whatever the uh, I mean uh, whatever the energy which is getting released by you by with the help or with the usage of nuclear materials or with the help of radioactive materials, then that type of energy is called as nuclear energy. Okay. All right, coming to these are about the advantages and disadvantages, and this was related to all the basics of nuclear power plant. I mean, what is nuclear energy? Okay, and what is atomic number, mass number, and what are the remaining definitions of isotopes, radioactivity, what is features of nuclear energy, fission, fusion. Okay, next is uh, merits and demerits of nuclear energy. Right. Here, two hydrogen atoms with mass number 2 means it is deuterium. Two deuterium atoms means isotope, which is isotope of hydrogen. Two deuterium atoms are getting combined, and they are again releasing one isotope of helium. It is not a normal helium atom. It is isotope of helium, which is helium 2 with mass number 3. As mass number is not getting verified. I mean, here you are having mass number 4. For two deuterium atoms, the mass number is 4. For helium atom, the mass number is 3. And I mean, mass number is lesser than this. The mass number of isotope of helium is lesser than mass numbers of deuterium. So, I mean, one neutron will be released, and the uh, fusion reaction equation will be balanced. Okay, right. Thank you. In the next class, I will deal with the working of nuclear power plant. What are the components which are there in nuclear power plant, and what all should be studied? Okay, we will deal in the next class. Thank you.